Welcome back, guys. Today's video is going to be covering hybridization and steric number. Now, hybridization and steric number are going to be very important when we go to determine the hybridization of atoms in a given molecule. So let's make sure we can break down hybridization and steric number one by one. So steric number is going to tell us how many things an atom has. So when I say things, I mean the atoms bonded plus the amount of lone pairs that it has. So if we look at an example, NH3, right, we can use this Lewis structure to help us determine the steric number of that nitrogen. Now, how many atoms does the nitrogen have bonded to it? It has 1, 2, 3 atoms bonded to it, and it has one lone pair, making the steric number of that nitrogen 4. Now, let's take a look at another example just to make sure we have this down. So imagine we have something like this. CH2 with an oxygen double bonded to a carbon, right? So this carbon has 1, 2, 3 atoms bonded to it, right? Now, it's important to remember, we're not counting the total number of bonds, right? I know there's a double bond here. We are counting the atoms bonded to it, right? So this carbon has 1, 2, 3 atoms bonded to it. It has no lone pairs. So the steric number of this carbon would be 3, okay? So now that we've broken down steric number, let's talk a little bit about hybridization. Now, hybridization can be a tricky topic, so let's walk through it very slowly. So hybridization is combining orbitals together into hybrid orbitals. So to better understand this, let's look at this Lewis structure CH4. So this carbon right here is making 4 covalent bonds to hydrogen, right? Now, we represent these covalent bonds, which we know represent the sharing of electrons between these two atoms, right? This carbon and hydrogen bond right here, for example, is going to be made up of these 2 electrons that we're sharing. Now, we depict it as this little line in this Lewis structure, but hybridization is going to tell us that there's more to the story, right? In reality, what's going on with this covalent bond is the orbitals that carbon has are going to overlap with the orbitals that hydrogen has and actually make that bond. Now, when carbon has to make a certain amount of bonds, what it's going to do is it's going to take its different orbitals that it has and mix them together to actually produce hybrid orbitals, okay? So let's see that play out. So what we're going to do if we want to determine the hybridization of an atom is we're going to use the steric number to help us determine that. So if your steric number is 4, your hybridization will be sp3. And I'll go over what sp3 means in just a second. Now, if steric number is 3, your hybridization of that central atom is going to be sp2. And if your steric number is 2, the hybridization is going to be sp. Now, we can follow this rule of thumb to help us. Once we determine the steric number of an atom, what we can say is that the steric number minus 1 will give us the hybridization. So when we see the steric number 4, we can say that the hybridization is sp3. When the steric number is 3, we can say that the hybridization is sp2. And when the steric number is 2, the hybridization is sp. So if we want to get our answer, we can use this. However, I like to go into a little bit deeper of an explanation so we actually understand what sp3, sp2, and sp means. Now, if you're actually looking for the hybridization, these are going to be your answer choices. But let's break it down a little bit further. So, where are we getting this sp3, sp2, and sp from? So, let's break down the electron configuration of carbon. Carbon's electron configuration is 1s2, 2s2, 2p2. Now that's from the periodic table. And if you need a refresher on electron configurations, make sure to check out my channel. I have a video on that. So, in general, right, regardless of what these numbers say, in general, we can see that carbon has s and it has p orbitals, right? So it has s and it has p orbitals, just in general, right? What we need to remember is that when we're talking about s orbitals, there are only one type of s orbitals, right? when we looked at the quantum numbers, right, and make sure to check out my channel for quantum numbers, we saw that the m sub L value for S, there's only one value for it, right? So S is on its own, right? There's only one type of orbital. And you don't even need to get into the quantum numbers to understand this. If you just want to remember as a rule of thumb, S only has one type of orbital. Now, when we write the p orbital, right, when we have an atom that has any p orbitals, what we're going to say is that there are three types of those p orbitals, right? There are actually three different ways that the p orbital can be arranged in space, and so that's why we see three different p orbitals, right? Again, looking at the quantum numbers, that will definitely help us out, but just in general, what you want to remember is any atom that has any p electrons, right, and by default, it's going to have s electrons, it's going to have one s orbital and three different p orbitals to work with, okay? Now, how are we going to use this to help us out to understand sp3 and what this means? So, carbon is bonded to four things, right? That means that this carbon is going to have a steric number of 4. And we can use the shortcut steric number -1 to help us out to understand that this is sp3. But why is that the case? So, carbon's bonded to four things. So carbon realizes, hey, I need to make 4 bonds. So what am I going to do? Well, I'm going to have to overlap my orbitals with 4 different things in order to successfully create this molecule. So what it does is it says, okay, I have 1 s and 3 p's to work with, okay? So what it's going to do is it's going to say, I need to make 4 bonds. So I'm going to take one of my s and all 3 of my p orbitals. We're going to put them together. What we can do is we can imagine these 4 orbitals, right, going in a pot, right? We're going to mix them all up, and out comes 4. Now that's a quantity, right? We're going to make 4 hybrid sp3 orbitals. So when I say sp3, that's actually a type of orbital, right? We're taking these individual orbitals, we're mixing them all together, and out comes our product, sp3 hybrid orbitals, right? And how many are we going to make of them? We're going to make 4. Now that's going to be perfect because now we can make 4 sp3 hybrid orbitals, right? And that's going to help us make those 4 bonds to hydrogen, right? So just as a summary, we can use steric number -1 to help us out. Anything with s and p character or s and p orbitals, it's going to have 1 s, 3 p's, right? We want to analyze how many bonds we need to make in order to determine our hybridization. So let's take a look at another example. Imagine we have our example from before, right? And let's imagine we want to make orbitals to overlap with our oxygen and hydrogen atoms, right? So carbon is going to say, okay, I need to hybridize, right, in order to make orbitals that can overlap with the oxygen orbitals and the hydrogen orbitals, okay? So what we can do is we can say the steric number of carbon is 3. 1, 2, 3, and there's no lone pairs. We can do steric number 3 -1, giving us the answer of sp2. But let's break that down a little bit further. So we know carbon has s orbital and it has p orbitals, right? And when you have p orbitals, you have 3 to work with, right? So we have s, we have p, and p, right? So carbon says, I need 3 overlapping orbitals, right? I need to overlap my orbitals with 3 different things. So let's take our s, right? You're always going to start from left to right. You're going to take your s, that's 1, 2, 3, right? So what we're going to do is we're going to take these 3 things, we're going to throw them in a pot, mix them together, and because we put 3 things in there, we're going to make 3, now that's a quantity, 3 sp2, right? 1 s and 2 p orbitals, right? 3 sp2 hybrid orbitals, right? And that's going to be perfect, right? If we have 3 of these orbitals, right, we can put 1 here, and 1 here to overlap with the orbitals of hydrogen and oxygen, and there we go. We have sp2. So, now that we've gone through hybridization and steric number, let's see if we can tackle some of these practice problems, right? So CH4, the hybridization of this carbon, right? Its steric number is going to be 4. So if we take a look, if the steric number is 4, we know that steric number minus 1, this is going to be sp3, right? So it's going to be an sp3 hybridized carbon, okay? Let's look at CH2O. So we just did this example. Just to reiterate, right, carbon steric number is 3. 3 minus 1 is 2. So this is sp2. Now, one thing I want to point out, when you have something like hydrogen, right, hydrogen's electron configuration is 1s1. So if you're asked the question, what's the hybridization of hydrogen? Well, the answer to that would be hydrogen cannot hybridize, right? In order to hybridize, you need to mix S with P. Now, hydrogen doesn't have any p orbitals to work with because its electron configuration is 1s. So for that reason, what we're going to say is carbon has these sp2 hybrid orbitals that are going to overlap simply with hydrogen's 1s orbital, right? So hydrogen is not going to hybridize. Now, oxygen can hybridize, right? Because oxygen is in the p block, right? Its electron configuration has s and p orbitals in it. So oxygen can successfully hybridize and overlap with carbon's hybridized orbitals, but hydrogen cannot. Okay, let's finish up with these last examples. So C2H2, right? We know hydrogens are going to be 1s, but what's the hybridization of these carbons, right? Well, the steric number of this carbon and this carbon, right? This is symmetrical, right? Let's see. It's attached to 2 atoms, and there's no lone pairs, right? It doesn't matter if there's a triple bond. It's still only attached to 2 things. That means the steric number is 2, and our hybridization is going to be sp. Okay? So it only needs to make 2 bonds, essentially, or overlap with 2 things, right? It needs to make 4 total bonds, but it only needs to overlap with 2 things. So what we're going to do, right, if we have our S and our 3 Ps, it says I only need to do 2 of these, put them in, and out comes 2 sp orbitals, right? Hybrid orbitals, okay? So it's going to be sp and sp. Lastly, we have NH3. And the steric number here is 4, right? 1, 2, 3, 4 things attached. So when the steric number is 4, the hybridization is going to be sp3. And nitrogen does have s and p orbitals, so it can successfully hybridize and overlap with those hydrogen electron orbitals. So hopefully you enjoyed this video. Please make sure to check out the channel for more videos, and make sure to leave a comment and subscribe.